Good morning, geometry. Today we're going to be going over our 5.1 notes. We're starting a new unit, Unit 3. We're going to start off with our warm-up. So for question A, what is the ratio of boys to girls? So go ahead and make a ratio, like a fraction. Make sure you reduce it. And then for question B, you're going to use your exponent properties to simplify. Go ahead and pause and come back. All right, for question A, if there's a total of 30 students in fifth period, so the total is 30, and there are 27 girls, what's the ratio of boys to girls? So we need to figure out how many boys there are first. So there ends up being 3 total. And then we're going to take 3 over how many are the girls? So 3 over 27, so ratio of boys to girls. And then make sure you reduce it. So this reduces down to 1/9. So for every 1 boy, there are 9 girls. That is your ratio. Question B, we're going to do our exponent properties. Power of a power, we're going to make sure we apply the exponent to both things inside of the parentheses. So 2 squared, x squared, and then power of a power, we go ahead and multiply those exponents. So times x to the 6. Then when we have 2 variables with this that are being multiplied, you add your exponent. So 2 to the second is 4, and then x to the 8th power, and that is your simplified answer. All right, so moving on to our notes. So these are going to be, our Unit 3 is transformations. Inside of transformations, there's a full umbrella of different types of transformations, and we're going to talk about one of those today. So transformations in general are going to change the position, the size, or the shape of a figure or graph. And then the transformation that maps a pre-image, so that's your original, is determined by a set of points on the plane to the corresponding set of points called the image, your new thing after we've done something. So we're going to have a rule telling us how we're moving something or changing it, and then that's going to be applied to our original to get our new image. Some of these transformations are going to be rigid motions. It's going to be a key vocab word. This is not going to change the size or the shape. So big picture here. It does not change the size or shape of a figure if it is a rigid motion, okay? So distances are going to stay the same, angle measures stay the same. If it says collinearity, so if anything is on a line already, it's going to stay on that same line together. If there's a distance between something, it's going to stay the same distance between it, no matter what type of movement there is. So the first type of rigid transformation is called a translation, kind of like a sliding motion. So a translation is going to move it the same distance in the same direction. And it's going to be moving it kind of like up, down, left, right, or a couple of those things. Okay. All right. So there are different types of rules for all these different coordinate situations. Translation rules for transformations. Sorry, for translations. The rule always starts with this thing. So saying the coordinate xy with an arrow. So every rule starts like this. And then from here, it tells you what are you changing about the x value or what are you changing about the y value. So if it's something adding to the x, we're going to move to the right. If we're subtracting from the x, we're going to move to the left. For the y value, adding is going to go up, and then subtracting is going to go down. Okay. All right, let's go ahead and try this one out. Let's go ahead and delete that real quick. Okay. So for task 1, we're going to draw our image, our pre-image, so our original, and then our image of a polygon. So I have my vertices A, B, C, and D, and we're going to use that rule. So first thing I want you to do is to graph your original figure. So A, 0, 6, so 0x up 6, so that's A. Don't forget to label. Okay, and then B, we have 4, 8. C was 4, 4. And D is 0, 2. It's not this one. Go ahead and connect that, and that's going to be our shape that we're moving. So we have a quadrilateral. Now we're going to apply the rule that they've given us. So we're going to add 4 to each x. And we're going to go ahead and subtract 2 from each y. And that's going to get us our new coordinates. When we do the coordinates for our image, so our new one, we label it as A with a little apostrophe. This is called a prime symbol. So this is called a prime. So that's letting us know if we're just looking at a graph, like which one's the pre-image and which one's the image, so we can tell them apart. So we're going to add 4, so 4, and then we're going to subtract 2, another 4, and then B prime. Add 4, we get 8. 8 minus 2 gets us 6. So the rule does tell us kind of exactly what we're doing. And we're going to continue that pattern. So adding 4, we get 8. Subtracting 2, 2. D, we're going to add 4 and subtract 2, which is 0. Once you have your new coordinates, go ahead and graph them. So I have 4, 4, and that's gonna, some of these are gonna overlap, and that's why we're gonna label it with A prime. And then we got 8, 6 for B prime, 8, 2 for C prime, and then 4, 0 for D prime. I'm gonna connect my dots. You should notice that this shape stays the exact same size and the same shape, right? Nothing has changed. We've just slid it down and to the right because that's what a translation does. It's just a sliding motion. It didn't rotate, it didn't flip. We'll get into those later this week, but it's just going to be a sliding motion. Okay. All right, on task 2, I'm going to walk through the first one with you, and then I'll let you try the second one. So task 2, I already have it graphed, and we're going to use the graph to write the rule. And so all our rules are going to start with the x, y, and the arrow. One strategy I have for you is when you look at your graph, identify which one's your pre-image and your image. So I'm looking to see which one has the prime symbols and which one doesn't. So the blue is going to be our pre-image, so our original, and we're going to the red that has the prime symbol, so that's our image. To find the coordinate rule, you're going to look for something that's going to, like you're going to pick a coordinate. So you can pick any coordinate to look at. I'm just going to pick A and A prime. So I'm going from A to A prime. So I want to know, I need to go this direction and then down. So the left and right is going to affect my x's. So I moved to the right, 1, 2, 3, 4, 5, 6. So I added 6. So the rest of my rule, I'm going to add 6 to each x coordinate. And then for the y's, we went down 1, 2, 3. So we subtracted 3 from our y's. And that would be your coordinate rule. You can always check it because it should match the other coordinates. So for example, if we checked it with coordinate C and C prime, so I go 1, 2, 3, 4, 5, 6. That still matches, and then down 1, 2, 3. So it's good. So make sure you check it with the other coordinates if you're not sure. Careful with your counting, but that's going to be your coordinate rule. So go ahead and try B, and then come back and check. All right, for question B, we have our coordinate rule that we're going to write. So we always start with our x, y, and then our arrows. We're saying, hey, take our coordinate and apply this thing. Look at which one is your image and your pre-image. So no prime symbols or apostrophes. It's going to be our pre-image. and this is going to be our image because it has the prime symbols. Pick any coordinate you want to start. I'm going to go with G. So I went 1, 2, 3, 4, 5, 6, 7 to the left. So that means I'm subtracting 7 from my x's. And then to get to G prime, I'm going up 1. So we're adding 1 to our y's, and that gets you your coordinate rule. Okay. Remember, you can always check this if you're not sure. All right, moving on to task 3. Task 3, I want you to write the coordinate rule for A and B. I've given you the coordinates for the pre-image, so your original, and the coordinates for your image for question A. You're going to try to come up with the rule. So look at what's happening with your x's and y's. Like, how are they changing? What is being added and subtracted to each one of them? And then for question B, I'm giving you the rule. And I want you to write me the coordinates of the image after you've applied the rule. So go ahead and pause and come back and check. All right, for question A, if I look at what's happening with all the x values, so go from -4 to -6, -1 to -3, -2 to -4, -5 to -7. So what operation is happening to every one of those? We're subtracting 2. So the x's are changing by subtracting 2 each time. And then for the y values, looking from 4 to 9, 2 to 7, 0 to 5, and 1 to 6, we're adding 5 each time. So that's how we can get our rule for question A. All right, question B, we're going to use our coordinate rule, so it's telling us what we're applying. So I'm going to subtract 3 from all our x's. Subtract 3 from all of the x values, and then we're going to add 5 to all of the y coordinates. So following the rule gets you your final answer. So anything we're going to apply to our x's, anything we're going to apply to our y's. So checking our coordinates, remember capital letters for points. Since we're doing the image coordinates, we're going to do a prime symbol. Don't forget parentheses for your coordinates. And then we have -3, 0 for k prime. We have -4, 2 for j prime, 0, 5 for I prime, and 2, 1 for h prime. So go ahead and check your answers. All right, we got one more task, task 4. This is where we're going to get into some graphing. So task 4, I'm going to set you up for what we're looking for. So strategy here is you have the coordinate rule for each of these, and we also have the graph. One thing that's not written out is when you don't have them written out, I would write out the original coordinates. So for this, we have coordinate D, which is 1, 1. I'm going to leave a little space so then I can write the prime coordinate underneath. And then I have coordinate E, 5, 0. Coordinate F, 3, 5. Coordinate G, 2, 4. So I would always write it out because then I can look at what's happening with the rule. So I'm going to subtract 4. And then if you notice the y, nothing's happening to it. So that means it stays the same. So I'll start this first one here. So if we do D prime, I'm going to subtract 4. So I get -3. And the y coordinate stays the same. So what I want you to do is finish A, and then you're going to graph that new image, the image on your graph, and don't forget to label it with the prime symbols. And then go ahead and try question B using that same strategy with that new rule. Go ahead and pause and come back. All right, question A on task 4. Let me finish our coordinates. Coordinate E prime, we'd get 1, 0. F prime, we get -1, 5. G prime would be -2 and 4. So when I graph this, go ahead and graph, so we get -1, 2, 3, and 1. Don't forget to label. E is going to be 1, 0. So E prime. -1 and 5 for F prime. And G prime is going to be -2 and 4. So when I connect all my dots, a good thing to check with translations is that your shape should look the same size, and it should look like the same shape. Minor details of not having straight lines when I graph, but it should look about the same. Okay, nothing should change, right? Your angle measure should stay the same. And then big thing here is don't forget to label your graph so you know which point is which. All right, let's check B. So for question B, if you started off with the strategy, label out your coordinates. X was 3, -5. Y was 2, -2. And Z, 2, -5. Then I'm going to use the coordinate rule. So we're going to subtract 3 from all our x's and add 2 to all of our y values. So I end up with 0, -3 for x prime. So 0, 1, 2, 3, -3. I'm going to label it on the other side, x prime. And then y prime, we end up with -1, 0. -1, 0. And then for z prime, 2, nope, that's the original coordinate. I have to actually do the rule. Let's do -3, so -1, and +2, so -3. So -1, -3, about here. Label and then connect your dots. And it looks like the same triangle, so that looks good. All right, that is translations. We're going to add more different types of transformations later this week. If there's any time left in class, you are welcome to start the homework. I'll check the homework off on Wednesday. All right, have a good day.